This is an easy question. You either are or you are not.
5.
What?
I have 5 younger sisters.
Okay, and you are the oldest or you're not?
Yes.
Okay,
I'm
yes.
Smack
Thank
in the
you.
middle, so I'm always the one getting yelled at.
What?
Can I run out to my locker? Because I can't find my homework.
Go ahead, Diana. Looking very crimped today, by the way. Crimped.
Oh, yeah.
All right. So, all right. Okay, so we're live. I think. Yeah, we're live. Okay, so, and on YouTube. So, you should have some kind of diagram that looks like this. We've got 2 parallel lines, no high fives for hiccups. Do you have any idea who I am? Any other class? Fine. My class. I will scare you. It's... All right. Call that L, call that M. They're parallel. I'm trying to help you, I promise. You don't want to be hit. All right. Just part of it, you signed this, right? When you filled out that syllabus at the beginning of the year, you signed on to this. It was a waiver. No one signed any of them. Thank you. Are you laughing or are you hiccuping? I cannot tell the difference. All right, so I believe I labeled my diagram like this, and if I didn't, I don't care. I'm doing it this way. All right, we had to prove some theorems that I didn't really even give you. We already did alternate interior angles theorem. We proved that 4 and 6 are the same, or maybe it was 3 and 5, I don't know. Depends on how I did my diagram the other day. So, did we already do same side interior? I believe we did. So now we have the exterior angles to do. You want to do the alternate exterior or the same side exterior first? Bailey. Alternate. Okay, so Bailey, give me an example of alternate exterior angles.
3 and 5. Oh, wait, no,
That's
that's interior.
interior.
1 and 8.
1 and 8.
No, 1 and 7.
1 and 7. There we go. Third time's charm. Alternate meaning opposite sides of the transversal. 1's on the left side, 7's on the right side. And they're on the exterior because they're on the outside of the parallels, right? This is the interior, that's the exterior. So we're going to prove 1 and 7 congruent or supplementary. What do you think?
1 and 2.
1 and 7?
I cannot.
All right, that's not good. 1 and 7, are they going to be congruent or supplementary? What do you think? We have descent amongst the ranks. So, check it out. Aren't 1 and 5 corresponding? And by corresponding angles postulate, which is one of the things we're allowed to use, we know that corresponding angles are always congruent if the lines are parallel, which they is. So 1 and 5 are congruent. What do we know about 5 and 7? Vertical angles, which means they're congruent. Remember, vertical angles theorem is Scissor theorem. Your word's not mine. Remember, vertical angles says that, look, the top angles are always the same, the side angles are always the same. Any pair of intersecting lines, it's true. Doesn't matter how they intersect, they're always going to be the same. So, we know 1 and 5 are congruent, and 5 and 7 are congruent. So guess what? 1 and 7 are congruent, right? 1 is 5, 5 is 7, therefore 1 is 7. Cool. The other thing we're allowed to use, by the way, is linear pair theorem, but we don't need that for this. So our goal is to prove that 1 is congruent to 7. Prove you spell with 1 O. Or at least I do. Okay? So, we're going to prove 1 and 7 are the same dumb thing. So, the proof is basically what I just walked you through, right? 1 and 5 are corresponding angles. So, by corresponding angles postulate, they are congruent. 5 and 7 are vertical. So, they're congruent. Then we do substitution. We write 1 and 7. So, I'm going to write something about angle 1 first. After I write the givens, of course. We are given that line L is parallel to line M. That's important, because otherwise none of this would be true. Yeah?
Can I have another homework? Sometimes at home, but
That's
But
exciting.
it's not here anywhere.
That makes sense, Diana. Because if it was here, it wouldn't be at home. Because this is not your home. And it will never be your home. You're never welcome here. You're never welcome here. All right. So we're given that the lines are parallel. Now what does that mean? Well, we know that angle 1 is going to be congruent to angle 5 by corresponding angles postulate, or cap, right? Remember that thing that we saw, the spoopy movie on Friday, right? The red cap. They're in the same relative location, 1 and 5. They're both at the top left corner of their intersections. And when the lines are parallel, corresponding angle postulate says, hey, if those lines are parallel, then the corresponding angles are congruent, which they is. So far, so good. 1 is 5. Now, we want to know about 1 and 7. So does 5 have a relationship to 7? Go ahead, Hannah. They're vertical angles, right? Scissors theorem. Here's the scissors. There's the angles. 5 and 7, they're congruent, right? So we know 5 and 7 are congruent, so I'm going to write that. We know it by vertical angles theorem, just like Hannah said. Cool. Well, now notice 5 is the same thing as 7. So wherever I see a 5, I can replace it with a 7. That's what I'm going to do. Why? Because I want 1 and 7 together. So 1 is congruent to angle 5. But instead of writing angle 5, I'm going to write angle 7. Remember, this sign, this congruency sign, an equal sign, right, means they're the same dumb crap. Means they're interchangeable. So I can switch out that 5 for a 7. We call this property what? Substitution. How are we feeling about substitution? We feeling better now? Seeing the connections? Me too. Your favorite day is when I have a substitute. I know. Swag box. Wicka, wicka. All right, so we're done. We proved 1 is congruent to 7. Yay! What does this mean? That means any set of alternate exterior angles, like 1 and 7 or 2 and 8, are going to be congruent. It's a fact. Because by the same dumb logic, 2 should be congruent to 8. Cool. Last one we needed to prove wasn't the alternate exterior angles, it was the what? We already proved the alternate exterior angles. What's the last theorem we need to prove? We did the alternate exterior angles. We've already done alternate interior. That was the first one we did. It's something on the exterior. Same side. Now, Mark, give me an example of same side exterior angles. 2 and 7. 2 and 8 are not. They're actually examples of alternate exterior. So, wrong again, Bailey. 2 and 8 would be an incorrect thing to say. 2 and 8 would be incorrect. I stand by my statement. So, 2 and 7, congruent or supplementary? Supplementary. We can prove that, right? That's what we're going to do. But let's talk about it, right? 2 and 6 are the same angle, aren't they? How do I know that 2 and 6 are the same? CAP, cap, corresponding angles postulate, right? They're both in the top right corner of their relative intersections. So they are congruent. Now, what do we know about 6 and 7? They're a what? Linear pair. Linear pairs by linear pair theorem are supplementary, right? So I'm saying 6 and 7 are supplementary, right? And 2 is the same thing as 6. So if 6 and 7 are supplementary, then 2 and 7 must be supplementary, because 2 and 6 are the same thing. So let's write that. We're trying to prove that 2 is supplementary. To angle 7. Okay? Oh, I have exciting news. I'm going to get contacts in a couple days, because now that I've moved to a different place, none of the orthodontists, none of the optometrists around here talk to each other, and they don't tell them, never give that man contacts. He doesn't blink, he reads music constantly, and his eyes dry out, and his corneas get scarred, right? They don't tell them that, because now I'm in a new area. So now I can go to the new doctor and be like, yeah, never had contacts, just give them a try. Let's try it out. And so I'm going to get them. You know what that allows me to do? It allows me to put these glasses right here, so that anytime one of you needs them, and you do, I can throw them at you, and you can wear them, because anything's better than nothing. You're welcome. You need them. Glasses of some sort, okay? Y'all need to go to the doctor together, like you're the eye doctor together, like you guys do to the optometrist. Not optometrist. Orthodontist. Words are hard, math is easy. 2 and 7 are supplementary is what we're trying to prove, given that the lines are parallel. That's all we need to know. Given that L is parallel to M, we should be able to prove that 2 and 7 are sup all day, every day. Jenna! I missed you.
I know.
Where's Chance?
I don't know.
Is he on his way?
Do they have his food?
I don't know.
He is here today, though, right?
Yeah, I see him on the bus.
Oh, wonderful. So he's probably just hanging out in the bathroom. Got it. All right, so L is parallel to M. We know that we want to prove 2 and 7 supplementary. So here's one way to do it. 2 and 6 are the same angle. Let's write that down. How do I know 2 and 6 are the same? By what? Why are 2 and 6 the same? You all right, Marissa? Gotcha, yeah. That's wild. All right, so 2 and 6 are congruent by cap. Now, we want to get 2 and 7 supplementary, so we need a statement that says something supplementary. What 2 angles are supplementary that might be helpful to get 2 and 7 together? 2 and 6, not supplementary. They are congruent. We already wrote that. How do we know 2 and 8 are supplementary? Hello, Chance. Linear pair theorem? Chance, I'm not sure why they're making that noise, but yeah, they're very excited to see you. You've excited them all. All right, so 2 and 8 supplementary? Nope, sorry, they're not a linear pair. Linear pairs have to be on the same line, and there only has to be 2 of them. 2 and 8 are on the same line because they're on the transversal, but look how many angles are on that line. That's not a linear pair. That's like a collinear. I can't say that word. All right. So,
That's all I have left.
make a sale quickly and move on. I will ban all capitalism in here from now on. From now on, this is communist Russia. Wonderful. All right. So 2 and 6 are congruent by cap. Now, we need to get a statement of supplementary, right? We need 7 in here. So 7 is supplementary at what angle? It's up to 8. But how does 8 relate to 2? Not a clear connection, right? What's another angle 7 supplementary with? 6. Check it out. We have a relationship now. We know 2 is the same thing as 6, and we know 6 is supplementary to 7. We know 6 and 7 are supplementary by a linear pair theorem, right? That's our favorite. They're both on the same line, and there's 2 of them, right? Right there, they make 180. That's the linear pair theorem. So now that we know 2 is the same thing as 6, they're interchangeable, right? So instead of saying 6 is supplementary to 7, I can instead write 2 is supplementary to 7. Good job, Hannah. And we do that by substitution. Let's swag box. Oui, oui. How you feel? How you feel about this? Because you're going to have to do it on Friday.
How do you remember which write that down?
Which go to which? What?
Like, how do you know which, like, postulates and theorems go to which?
So when I said 2 and 6 are congruent, one of the ways I can say that they are is that corresponding angles, right? Because that's what they are. So that's why I say by corresponding angles postulate, those 2 are congruent. For this one, 6 and 7 supplementary. Well, how do I know 6 and 7 are supplementary? It's because they're a linear pair, right? Linear pair theorem is my reason. What is what? VAT? Vertical angles theorem. scissor theorem. So the three things you have to prove, or the three tools you have to be able to prove something are cap, corresponding angles postulate, like 2 and 6 are the same because they're in corresponding spots, right? Vertical angles, like 1 and 3, because they're scissor theorem, right? And then linear pair theorem. 1 and 2 are supplementary, not congruent, right? They're on the same line. Same thing with 2 and 3. Put that away, yes.
Is that test we just took for this quarter? Like, I haven't gotten it back yet. Like the official grade.
We graded it in class last Friday. Or no, we graded it in class last Monday.
I know, but I did mine for you to check this out.
I graded it, and you did better than you thought, I believe.
A passing grade?
I can't remember off the top of my head, but we're going to review it today. That's why I'm going to call people up in a little bit to look at grades so you can see it. But I want you to know you did way better than you thought. I don't remember what it was, but I remember it was way better. Okay? You're going to be all right. All right. So, now, let's take a look at this thing. This guy, get it out. If you weren't here yesterday, I've got one for you. Who wasn't here yesterday? Chance wasn't. Natalie wasn't. I already got Natalie. Here you go. Mm-hmm. All right, so we're going to do some of this together. It says, given measure of angle AFB, well, that's this guy, and EFD, that's this guy, are equal and equal 50. Well, we should probably write that down. Write that down, write that down. All right. They also tell us points BF and D and EF and C are collinear. What does it mean to be collinear? On the same line. So the reason they tell you that is so that you know that BFD is a line. And that EFC is a line. Because look, AFD, that ain't a line, right? AFD, very easy to tell because it's bent, right? But maybe BFD is bent. Maybe that's bent a little bit. I can't tell, right? It's hard to tell. So they're telling you, no, it ain't. That's a line, that's a line. We have an X here, and we just got a little appendage sticking out there. All right, so state whether each pair of angles is a pair of vertical angles, a linear pair, or neither. Then tell the angle measure for each. Well, we're going to tell the angle measure up here. Okay. Let's do these. It says BFC. This one right here. We'll do it in orange. And DFE. That's this one right here. DFE. Already done in pink. What's their relationship? What kind of angles are the pink and the orange? Are they vertical, linear, or neither? Vertical, right? Scissor theorem. The scissors are right here. Ta-da! Top and bottom are the same. One of these days I'm going to slice off one of my fingers. I'm just going to keep going like a champ. So they are vertical angles. And we know that they're both going to be 50, right? That's what vertical angle says. Of course! BFA, that's this guy right here, and DFE, these guys. Are they vertical? No! Are they a linear pair? No, because there's 3 angles on this line. Linear pair means 2. Pair, like the fruit, right? So there's more than 2 here, so they're not a linear pair. They're neither. They're not a linear pair. Because if they were, we would be able to use linear pair theorem, right? And linear pair theorem says that they're supplementary. Are those 2 supplementary? Hell no, right? So, no. Neither. How about BFC? This guy right here? That's the orange one. And CFD. That one right there. Marissa. BFC and CFD. I have taken the pleasure of making that one blue and that one orange for you, so it's really easy to see. Okay? Are they a linear pair, vertical angles, or neither? Why are they neither? Tell me why they aren't vertical angles.
Wait, they're not vertical angles
Yeah, tell me why they aren't.
because they don't match.
Like, these are vertical angles, right?
Yeah. Well, because that one's on the side.
Yeah, exactly. So we have the top part of the scissors and the side part. Remember, vertical is top and top, left and right. Okay, good. So why is this not a linear pair?
Because wait, it is.
Okay, well, make up your mind. Tell me why it's a linear pair.
I don't know.
What made you change your mind?
Because it's like that's
Yep, collinear is the same thing as linear pair, okay? Collinear Collinear just means they're all on the same line. So check it out. These three angles, collinear. They're all on the same line. They're not a linear pair, though, because there's three of them. Right? That's the only difference. Collinear means anything on the same line. So here's a line. Here's a bunch of angles. Right? Those are all collinear. None of those angles are a linear pair. That's a linear pair. So it is a linear pair. So they're a linear pair. Now, what do we know about linear pair theorem? It says that if two angles are a linear pair, then what? They are supplementary, which by definition means they add up to 180. So, if that's fitty, Bailey, what is this angle going to be? 130 degrees. Very good. Then it says AFE and AFC. Yeah, what? Linear pair. AFE and AFC. Wow. Macy, you're being so brave today. So AFC is that purple angle, the big one, right? Are they a linear pair? Macy says yes. Is this angle and the green angle, the purple and the green, are they a linear pair? Yeah, they are. They're two angles that make up an entire line. Two, right? The big one here, the small one there. Now by angle addition postulate, we know that the purple angle is going to measure how much? 100 total, right? That's angle addition postulate. You're allowed to add up the pieces and get the big one. I hope you're starting to get that now. Now, if they're a linear pair, what does the purple angle and the green angle have to add up to? Bailey, 180. So if that guy's 100, Chance, how much has this got to be? 80. Cool. So they're a linear pair. Rest is on your own. Turn the page. Define each term. Transversal. Sounds like a wrestling move, but it ain't. Someone tell me in their own words what a transversal is.
A math term.
Someone other than Bailey, because I'm tired of talking to her. It's a line that does what? Hannah, what does it do? A line that does what?
Cuts through two lines.
Cuts two other lines.
Parallel lines.
Nope, don't have to be parallel.
Oh, okay.
The magic happens when they're parallel. That's when all the other theorems pop up. But even if we have two lines that aren't parallel, like obviously aren't, this blue line is still transversal.
Okay.
It's just not as cool. Corresponding angles. Oh, I forgot. We have to give an example of each. What's the example of a transversal in this diagram? Where's the transversal in this diagram? Bailey, I'll talk to you again.
T.
Line T. Or just cursive T. I don't know. That's ugly looking. It looks like that symbol, the kanji symbol for Fire Blast from Pokemon. Corresponding angles. Angles that are in the same relative position. Remember, relative, not the exact same position. They're the exact same position, they mold together into an abomination. Now, what do I mean by that? Well, an abomination, kids, no. What I mean by relative position is this. If you look at their intersection, right, the top intersection, 1 is in the top left corner. If you look at the bottom intersection, 5 is in the top left corner. Are they in the same position? No, because they'd be right on top of each other. But they're in the same relative position. If you look at their relative position to their intersection, top left, they're in the same spot, right? And we know that there's a postulate that goes with that. If those angles, or if those lines are parallel, then those guys will be congruent. That's cap. So an example of corresponding angles would be angle 1 and angle 5. Rest are on your own. Think about what it means. Alternate interior angles. Angles that are on alternate sides of the transversal that are in the interior. Right? The definition is pretty much in the name. Yay, mathematicians. Tell which angles are congruent. List all of them. That's number 9. Tell which angles are supplementary. List all of them. That's number 10. on your own. Yes,
Do we have to explain or can we just list them?
you can just list them.
Okay.
Well, I'm gonna call your name. If you want to come up and check your grade, go ahead. And if not, just say, nah, I'd rather not. School is for fools. Yeah, tell me that. Say school is for fools. All right, we're ending the live stream. Why?
Why?
What do you mean why? What do people want?
I think you forgot a couple words out of that sentence.
Football.
No.
Today's